In the previous class, we have seen the theoretical concepts of what is transit surveying, what are the different methods, and what is latitude, longitude. Then we have seen how to determine the correction to the latitude and the correction to the departure by using the transit and the Bowditch method. We have seen in the previous class the theoretical concepts we have seen. In today's class, we are going to concentrate our study on the how to solve the problems or how to determine the correction to the latitude and the longitude by using the Bowditch and the transit rule. Now, following are the observation taken in a closed traverse, closed balance traverse. Now, determine the correction to the latitude or correction to the longitude departure by using the Bowditch and the transit rule. Okay, now this is the problem. It is given will be given to you. In the problem, the length, latitude and the departure will be given to you. You need to determine the correction to the latitude and correction to the departure of any side that we need to do it in this particular problem. Now, the length of the line AB is 200, the latitude is minus 173.2 and 100, and then BC is length is 130, latitude is 86.6, then BC is latitude is 0 and departure is 130, and CD it is length is 100 meter, latitude is 86.6 and departure is 50, then DE it is 250 length and 250 is latitude, and then departure is 0. Then EA is 320, that is length, and then latitude is minus 154.9 and departure is minus 280. Okay, so this is the problem will be given to you. Now, first, after giving the problem, the first thing what you need to do is, right, you need to write this length, latitude and the departure. And first thing what you need to do is, you need to find out the total error in the length and the total error in the departure. Now, how you can do it? The total error in the length, latitude and the longitude, right? Latitude and departure, how you can do it is, you can add all these, right? You can add all these length, right? The latitudes, whatever has been given to you, right? That you need to add it, and you need to determine the total error in the latitude, right? These are the latitudes, right? And these are the departure. Now, the thing is, when the sigma L is equal to 0 and the sigma D is equal to 0, then only the there will not be any closing error will be there. Now, here when you are going to add all these latitude, you can find that you have got the answer, it has 8.5, right? That means there is an error in the latitude, right? Now, when you add the departure, all the departures, right, you have got the answer as 0. That means there is no error in the departure. So, you need to apply the Bowditch method for the length, your correction for the latitude, right? You need to apply. There is no correction required for the departure, right? The first thing when you get the question, the first thing what you need to do is, you need to find out the how much error is there in the latitude and how much error is there in the departure, that you need to find it out. So, when you have added it, you have found that there is an plus 8.5 error is there, then in the departure there is an 0 error is there. So, there is no correction that has to be applied for the departure, right? You need to apply the corrections for, or you need to find out the correction to the latitudes. Now, how you can do it? First, you need to add it. You are going to understand whether you need to do apply the for the latitude correction or the departure correction. Then the length. Now, the total length of that side. What we need to have is, we need to find out the total length measurement, because what your formula says is sigma L. Your sigma L is nothing but it is nothing but the perimeter of the traverse. So, in order to find out the perimeter of the traverse, you need to add all the lengths. So, first after giving the problem, you are going to add all the lengths, you are going to add all the latitude, and you are going to find what answer you are going to get. Then departure. If the latitude and departure, if it is equal to 0, then there is no correction that has to be applied. If there is an error is there, then you need to go for the correction. This you need to understand when you are going to solve the problem. So perimeter you have determined by adding all the lengths. That is, it is the answer, the perimeter is 1000. So this value you have already determined it is 1000. Here it is going to become 1000. Okay, the length of perimeter of the traverse is 1000. Then you need to find out, right? You need to find out how much the CL. Now what is this CL for? CL for correction of the latitude for that line. Now you have found out this as a 1000, this as a 8.5, and this as a 0. Now the correction for latitude you needed to apply. Then correction for the departure you needed to have it. First you are going to add it, and where you need to see whether it is 0. If it is not 0, then you should go for the correction. So correction, right, as you know that the departure does not require any correction, straight away you can write it as a 0. Now here the correction for your latitude, what you needed to do is you needed to utilize this particular formula. So what does a formula for each line, right? For each line you needed to apply for the corrections, right? Each line you needed to apply the corrections. What correction, how you are going to do it? By using this particular formula. Now total error in latitude multiplied by length of that side divided by perimeter. Now total error in latitude is how much? It is 8.5. So first formula what I have used is, it is the total error in latitude, that is 8.5 multiplied by the length of that side. Now length of that side means for the first one, that is the line AB. So I have taken it as a 200 divided by perimeter of the traverse is how much? Total perimeter is 1000. So answer I have got it as 1.7. Now for the second case, what should be your the total error, right? So total error is nothing but again it is 8.5. The length of that side is again 130. Then again it is 1000. Now let us do for the second, right? Now we will apply for the second, the correction we will apply. I will show the one correction, then similarly you will be applying for the all the others. Okay, so it is, we are going to have 8.5, that is nothing but the total error in latitude multiplied by the length of that side. Length of that side is, we are going to have 130 divided by 1000. Why 1000? Because the perimeter of the traverse. Okay, so we have got the answer as 1.105. So I have written it as 1.105. Okay, now similarly again the total error 8.5, then length of that side is 100 divided by 1000, I will get it as 0.850. Then again 8.5 multiplied by 250 divided by 1000, I will be getting this answer. Then again 8.5 multiplied by 320 divided by 1000, I will be getting this answer. As I have told, for departure you does not require any correction. Now the corrected values, right? Now this much the correction you needed to apply. Now the corrected values, what you need to have is, you need to have utilize the formula LC, that is correction for the correction, your latitude correction. You need to apply a formula LC is equal to L minus capital L minus CL. Now what is capital L? Capital L is minus 173 for this line, right? Minus CL. What is CL? That is 1.7. So if you do minus 173.2 minus, now this is again 1.7, you are going to get the answer as minus 174.9, which is present over here. That is minus 173.2 minus 1.7. So you will be getting it as 174.9. So this I have written. Similarly, again you need to write 0 minus 1.105, you will be getting minus 1.105. 86.6 minus 0.850, you will be getting this answer. Similarly, you need to go for all the others, and at the end, if you are going to add it, you will be getting it as 0. So here we are going to get it as 0. Then here DC we are going to get it as 0. So this is how you are going to apply the Bowditch rule, and you are going to get the corrected values by using the Bowditch method. So here remember the sigma of L and sigma of D, again it should be equal to 0. First you need to find out whether there is a correction is there. If correction has to be applied, then you need to use this formula. By using this formula you need to find out CL and CD, and then L you will be using LC is equal to L minus CL, right? Then you are going to add it. Now the corrected values, if both are coming equal to 0, then you have done the correction. Okay, then your problem is over by using the Bowditch rule, right? Now we are going to solve the same problem by using the transit rule. Okay, now in the transit rule, again what you need to do is the same problem we have solved it by using the transit rule, right? You have determined the length perimeter L, then latitude, whether you need any correction or no, you have determined it. Then the departure you have determined it, right? Adding these you have determined it as 0, adding all these you have found it as 8.5, and since it is 8.5, since the sigma L and sigma D are not equal to 0, what you have applied is you need to go for the latitude correction. Okay, so here the formula, what is the formula says in the transit rule? That is the correction to the latitude multiplied by the length of that side divided by arithmetic sum of the latitudes or departure. Now what you need to have is, in this particular formula we are not going to bother about these minus and plus signs, right? In order to find out the arithmetic sum, we will be all taking it as positives only. Okay, in the transit rule we are not going to take care of the arithmetic sums of latitude or arithmetic sums of the departure. We are going to take it as positive in order to find out the arithmetic sum. Okay, so we have found it, this is 8.5 and again 0, so we found that this requires a correction. Now what formula we needed to apply? The correction of latitude. The correction of latitude is, total correction of latitude is 8.5. Now what is the latitude of that line? What is the latitude of that line? Here, as I have told, since though here it is minus 173.2, we in this particular transit rule we are going to take it as positive only. So 173.2 divided by 664.7. Now where this 664.7 has come? Now what are the arithmetic sum of all the latitudes, right? The arithmetic sum of all the latitudes, that is 173.2, 0, 86.6, 250, 154.9, right? If we take it, it is going to become equal to 664.7. So if I simplify it, it is going to become equal to 2.215. Okay, so it is going to become equal to 2.215. Now again, what formula I will be applying? Now L minus CL, the corrected values. In order to find this, what formula I will be applying? I will be applying L minus CL. So what is L? Minus 1. Here again the corrected values. In order to find out the arithmetic sum only, we are not going to consider these negative or positive value. But again, when we are going to write the corrected values, again we are going to consider these minus values. So minus 173.2 minus, it is 2.215. So we are going to get it as minus 175.415. Then again 0 minus, again 0, right? So it will be 0, no correction will be there. Then 86.6 minus 1.107, we are going to get it as 85.493. 250 minus 3.197, again we are going to get it as 246.803. Then minus 154.9 minus 1.981, we are going to get it as minus. When we are going to add it, we are going to get it as the 0 values. So similarly, you need to go for the departure. Again, departure as it is, you can write it because here we are going to get it as 0 itself. So this is how we are going to have the latitude, and we are going to apply the correction for the latitude and the correction for the departure by using the transit and the Bowditch method. Here you need to go to solve many problems from the textbooks, right? Only one, again in the notes also there is one more problem. You can solve that problem also in order to have these problems on the Bowditch method, and by using the transit method. In addition to this, you also need to go for the some more problems from the textbook, right? Now this is regarding the Bowditch, and by using the transit rule how to solve the problems. Now there is one more problem that may be going to be asked to you. In order to find out that particular problem, right, in order to solve that particular problem, you should know how to, till this you already know it, how to determine the closing error by using the transit and the Bowditch rule. Now the closing error can also be computed by using the formula. Length of the closing line, that may be also going to be computed by using the, if we want this length, if this length, right, as I have told, what is an closing error? If the both the latitude and starting point and the end point, if it is not going to be meeting each other at one point, then we call it as an closing error. Now in the, might be the, you may get the problems like, what is the length of this closing line, that may be asked to you. So in order to find out that length of the closing line, what formula you are going to be applied is, you are going to apply the sigma square of the latitudes plus sigma square of the departure, the whole root. If you make it, you are going to get out that length, and the tangent length, that theta, in order to determine the relative error of closure. If you want to determine that the closing error E, this line length is nothing but we call it as an E divided by the total length of the traverse P. This total length we can find it out. So the relative error of closure, that we can determine by using this particular formula. So we are going to solve the problem on that, the simple form problem on that, right? So here the following are the length and the bearings of the traverse ABCD. The bearings are referred to magnetic meridian having the value of magnetic declination being 5 degree 30 minutes west. Convert the observed bearing to the true bearings and find the error of closure. We need to find out the error of the closure. Now the length, bearing, this latitude and departure will be given to you, right? The length, bearing, then latitude and departure will be given to you. You need to first find out the and here they have mentioned that there is a magnetic declination of 5 degree 30 minutes is there. So first, whatever the bearings you have got, you need to apply the correction for that, right? You need to apply the correction for whatever the magnetic bearings you have got it, right? So length, bearing, latitude, departure will be given to you. Then you need to apply the correction for these bearings, right? Since there is a magnetic declination is given to you. So the length is 470, the bearing is 343, and corresponding latitude is 436, departure is minus 173.3, and 635, bearing is 87 degree 50 minutes, latitude is 84.72, departure is 629, right? This is given to you, right? Now since the magnetic declination is there, first thing you need to do, you need to do the conversion. So how you are going to do the conversion? As we have solved the problems in the magnetic declination, this is your bearings, right? Since it is towards westward, what we need to do is we need to reduce this value, right? So we are going to get the new values as 343 degree 52 minutes, 5 degree 30 minutes, 343 degree 52 minutes minus 5 degree 30 minutes west. We are going to get it as 338 degree 22 minutes. Then again 87 degree 50 minutes minus 5 degree 30 minutes west. We are going to get it as 82 degree 20 minutes. 172 degree 40 minutes minus 5 degree 30 minutes west. We are going to get it as 167. 265 degree 12 minutes minus 5 degree 30 minutes west. We are going to get it as 259 degree 42 minutes. Now first thing what you need to do is you need to have this latitude and departure values, right? So you need to add it. You are going to get it as 1.82. Departure, you need to add it. You are going to get it as minus 1.28, right? Now the closing error. Now this is your sigma L and this is your sigma D. So closing error you can determine it by using the formula or square root right? Sigma L square plus sigma D square. So L square D square, you have got the closing error E, right? This is your value E, 2.225. This much of closing error is there. Now total perimeter. Now total perimeter, how you can get it? By using by adding all these values, right? You can determine it. So you after having this closing error, if you are determining all this, you are going to get the answer, right? You are going to get the answer, the relative error, closing error. If you are going to add it, you are going to get the answer like this. Okay, so this is how we are we have determined we have solved the problems on the transit and the Bowditch rule. We have solved the problems. In the next class, we are going to see the further things that has to be studied. Okay, thank you.